Hi friends, welcome to Gate Academy. In this video, I will give you a brief introduction on the topics I will discuss in P-Drive or G-Drive courses of Gate Academy. So, what exactly is a P-Drive course? I mean, many people may be knowing that the idea of P-Drive courses is giving you all the topics in a pen drive format so that you can go through the videos for different topics, different subjects and learn the subjects and apply that to get to crack various examinations like GATE, engineering service examinations and interviews of the PSUs, and some state service examinations also can be cracked, because in state service examinations also the theory part or the conventional part or the subjective part will not go out of these topics. So, the topic I will be discussing today here is water resource engineering and hydrology, and in that first one I will be discussing is water resource engineering, whose weightage in GATE is 2 to 4 marks and engineering services is 15 to 30 marks. So, you can see here GATE weightage is only 2 to 4 marks, and you can think that you can neglect, but no, because everyone is going to solve this question, because it is very simple questions are being asked from this subject. So, do not neglect these type of subjects like water resource engineering, hydrology, open channel flow. You can see like these are only 2 to 4 marks and people are not giving concentration for this one and they are losing marks, because these are basic questions and everyone is scoring that, and even you also have to score that. So, coming to the chapters or topics that I am discussing in water resource engineering, sometimes this is also called as irrigation engineering. So, the first one is global distribution of water. In global distribution of water, the name itself says how water is distributed in the world, like how much portion in ocean, how much portion in the fresh water, generally 97.5%, 2.5% in the fresh water, how much is present in the form of ice and how much is present in the form of liquid. Everything will be discussed in the global distribution of water. Next, see, the next interlinking is there is a water that is available and how you are going to use that water. Multi-purpose use of water will be discussed in the second chapter. Multi-purpose use of water is drinking water, irrigation, hydrology, hydropower. Next, ecology and agricultural, non-agricultural uses, and then navigation. There are many multi-purpose uses of water. So, coming to multi-purpose use of water, I said drinking water. Next one is irrigation, right? So, water resource engineering mainly deals with irrigation. The third chapter is irrigation. So, irrigation, what is irrigation? I mean, irrigation introduction and definition, all those things. Irrigation means what exactly? Like it is providing water to the field or crops for its growth. So, I mean, a definition where the definition will be used, definitions or all those things, it might be asked in engineering service examinations in conventional part. That's it. That's why introduction and definition will be given to you, and then advantages and disadvantages of the irrigation. Advantages, why you are providing water to the field for its effective growth, that means in order to increase the yield, right? So, and then disadvantages, the direct benefits and indirect benefits. Direct benefit is increasing the growth. Indirect benefit is in order to provide the irrigation, you will construct a dam. Because of constructing dam, hydropower electricity will be generated, drinking water supply will be given, navigation facilities will be provided. So, those are indirect benefits of irrigation. And disadvantages is, if you provide more amount of water to the field, what happens? Waterlogging. Because of waterlogging, many effects will be there on the growth of the crop, and then because of more amount of water, there will be spread of diseases, because many flies, mosquitoes will be breeding on that water. So, different advantages and disadvantages will be discussed in this one. And then types of irrigation, maybe you would have heard or seen in your fields, like surface irrigation, subsurface irrigation, and then sprinkler irrigation, drip irrigation. Different types of irrigation will be discussed, and this is an important topic in your engineering service examinations, because they might ask, and there is a problem in border strip irrigation, that problem is also asked many times in engineering service examination. So this gives a major amount of marks. And then quality of irrigation water, this is also being asked. Quality of irrigation water means you can't provide drainage water to the field, right? Because if you provide drainage water, what happens? There will not be growth of crops, because there will be microorganisms, there will be different salts that affects the growth of the crop. So you have to provide a clean water which is free of sediments, or the concentration of sediments has to be less, concentration of salts has to be less, concentration of boron has to be less, or what are the concentration that has to be less. We will be discussing all these things, the salinity, alkalinity, and what are the ions that has to be present, what are the ions that is not to be present in the water is discussed in the quality of the irrigation water. That means before providing this water to the field, what you will see all the parameters that is present in the water. So here there is a formula that will be asked for your gate question. I mean, in one of the gate question they have asked estimated sodium percentage, or SAR, sodium absorption ratio, was asked in one of the gate question. I mean, one of the year a gate question is asked, and in engineering service also a 10 marks question was asked on the quality of irrigation water. And types of irrigation, here also a 10 marks question, a theoretical question may be asked from the types of irrigation. Now coming to next one, water requirement of crops. I have given you introduction about the irrigation. Irrigation means artificial supply of water to the field. Artificial supply means a river is going, you have constructed a dam and you have raised the water level and you are utilizing this water for the fields, right? So that is artificial supply. Naturally it is not going into the field, you are providing it artificially by construction of dams, weirs, barrages, canals. Many things can be constructed. There are many irrigation structures. So next, that is irrigation. Now how much amount of water you have to provide to the field is what we'll discuss in water requirement of crops. The name itself says water requirement of crops, means how much amount of water is required by the crop for its growth. In that means when you will provide water to the field, before sowing and before harvesting, right? That means just before sowing the seeds into the field, you will first clean the land and then you will water it, then you will sow the seeds, and then before harvesting you will do your last watering, right? So that is water requirement of crops, and that period is called crop period. And we will also discuss different types of base periods, like base period and then duty. Duty is indirectly called as, like, for 1 unit of water how much area is being irrigated is called duty of that water. So what exactly is duty? And delta is the depth of the water that is present in the field. Delta is the depth of the water that is present in the field, and the relationship between base period, duty and delta. So this relationship, many questions, I mean maximum number of years the questions is asked based on this relationship only, base period, duty and delta. And this will be the in-depth relations and in-depth proofs will be discussed in your pen drive courses. And then duty at various places. Various places means, see, first you have provided water, I mean you have raised the water level in the dam and you are providing this water to the canal, and then water moves in the canal and then it goes into the field, right? During the movement there will be some amount of losses, and then during this moment there will be some amount of losses, and finally it reaches to the field. So what is the duty of water at field? what is the duty of water at this in the canal, what is the duty of the water at the entrance of the canal, at exit of the canal, at the exit of the branch canal, at the exit of distributary. I mean there are different canals. At each and every point what is the duty of the water, that will be discussed in this topic, duty at various places. And then irrigation efficiencies. Efficiencies means, what is efficiency? Output minus input upon input, or input minus output upon input. How much amount of water you are giving, how much amount of water it is reaching, right? That is efficiencies. And different types of irrigation efficiencies is like conveyance efficiency, application efficiency, storage efficiency, distribution efficiency, many deficiencies. Problems is also asked on irrigation efficiency. They will simply ask what is the irrigation efficiency, or this is the irrigation efficiency, what is the amount of water that is required at the starting, at the ending. So this is also an important topic. Gate questions will be asked from majorly gate questions are asked from here, and then engineering service examination questions, conventional questions majorly. I am not talking in engineering service, there will be objective questions, unconventional questions, and conventional questions will be asked from irrigation efficiencies. Means not simply what is irrigation efficiency, they will interlink irrigation efficiency with this one and with the other topics, and with the other topics they will interlink, and they will generate a question and they will ask you to solve that question. So different types of irrigation efficiencies will be discussed over here. Next topic is soil moisture relationships. Soil moisture relationships means here I'll discuss some concepts called field capacity, permanent wilting point, temporary wilting point, readily available moisture, and amount of moisture that is required. So name itself says readily available moisture means the moisture that is present in the field. Soil holds some amount of water for the growth of the plants, right? So that is called soil moisture relationships. That means the depth of the water that is present in the soil is called as, or how much amount of depth of water that is present in the soil is found out from soil moisture relationships. And this is also an important concept from both gate and engineering service point of view. So here based on field capacity or permanent wilting point means the name itself says permanent wilting point means it is not going to, it is totally wilted up. So it regains the strength only after providing water to it. That is permanent wilting point. And then what is temporary wilting point, and then what is the amount of moisture that has to be added to bring the water to its field capacity. Everything will be discussed in soil moisture relationships, and the entire topic is important for both gate and engineering services point of view. Many years, even in the last year, you can see the questions are asked from soil moisture relationships. Before year it is asked from B, D and delta. That just based on that relationships, they will give you delta, they will ask you to find out duty, and they will give you base period, they will ask you to find out delta, anything. So water requirement of crops is the important concept for both gate and engineering service point of view, and it is also the scoring concept. Many times, sometimes people read only this concept and they have scored. I mean, if you are lucky, but don't do that ever. You read each and every concept from both the point of view, from both gate and engineering service point of view. You have to read each and every topic. The next topic is theory of consumptive use. Here, theory of consumptive use, in this I will be discussing consumptive use. What exactly is consumptive use? Plant absorbs some amount of water from the field. In that, plants will have leaves. From the leaves, water will be evaporated. That is called transpiration, and some amount of water is evaporated from the field. That is evaporation. Combinedly, you will call it as evapotranspiration. Based on the evapotranspiration, based on this one, that means this amount of water is evapotranspirated. you provide this amount of water, this amount of water is evapotranspirated. So based on this one, that means you are providing 10 mm of water, 2 mm is evapotranspirated. That means if you measure this one, if you measure 2 mm, you say that 10 mm amount of water is required, or 10 mm amount of water is absorbed by the plant. So that is how it is calibrated. That means we calculate evapotranspiration, we calibrate it to the amount of water that is required in the field, and then we will use that in the soil moisture relationship. See, everything is interlinked over here. That means you're going once if you know consumptive use, then only you can use soil moisture relationship. That is the idea. I mean, while doing the proofs, you will come to know how it is interlinked, and based on consumptive use, that means it is the amount of water that is required per day. So based on this, you can find out the frequency of the irrigation. That means after how many days you have to irrigate the water. That means for these many days that means for 10 days you have provided 10 cumecs of water. After 10 days you will provide one more 10 cumecs of water to bring that to the field capacity. So based on the consumptive use, you can find out the frequency of irrigation. What exactly is each and everything will be discussed in the P-Drive courses. Next, types of, as I said, irrigation requirements. So irrigation requirement means it's very simple, calculation the amount of water required. Irrigation requirement, consumptive use irrigation requirement, next net irrigation requirement, next gross irrigation requirements. These are the different types of irrigation requirements that will be discussed in types of irrigation requirements. And methods to determine consumptive use, that means I said that is indirectly methods to determine evapotranspiration, that is also discussed here only. So different types of methods is there, like lysimeter method, and then Blenny-Criddle equations, Penman's equations, experimental plot method, and input inflow outflow method. These are the different methods that is used to find out the consumptive use. Remember, consumptive use is very much important to find the frequency of irrigation. So based upon the frequency of irrigation, yield of the crop is dependent, and this whole topic is generally more important from engineering services point of view. But sometimes if he wants to make the paper tough in the sense it just becomes lengthy, then he'll ask you a question from consumptive use irrigation point of view. He'll just interlink consumptive use with irrigation efficiencies, and finally you have to calculate the depth of the water that is required. So these both the things will be interlinked and questions will be asked. See here, irrigation efficiency, soil moisture relationship, consumptive use, all these things will be interlinked and questions will be asked for. And if you score this question, generally people don't attempt that question because it is very lengthy, but if you do this question, you have upper hand over all the other people. So that is one of the great advantage of reading this consumptive use concept. Next, coming to canal irrigation system. Canal irrigation system, till now we have discussed what is irrigation, amount of water that is required for the irrigation, and all those things. Now how do you get water? You get the water to the fields from the canals. Remember, I am talking only from irrigation point of view. Irrigation is artificial application of water to the fields. So canal irrigation system. In canal irrigation system, first we will discuss where you have different definitions, like what is a canal, what is a lined canal, what is an unlined canal, and what are the advantages of the canal, what are the disadvantages of the canal, and where you can provide, what is the site for providing the canals. A canal is to be provided so that more amount of fields is irrigated. Sometimes canals is people, you generally think that you are providing canal only for irrigation, but they'll use that for drinking water purpose also. So many things has to be considered, and the length of the canal should be very less so that losses will be less. You have to see from economy point of view also. because the idea is you have to reduce the losses, increase the discharge. That is the major idea in lined canals. So everything will be discussed in canal definitions, and what is the gross command area, culturable command area. Gross command area means when a canal goes, it irrigates all the area, but in that area there will be institutions, there will be fields, there will be residential area, and all those things will be there, and you are not going to irrigate the residential area, you are not going to irrigate the institutional area, right? You are only irrigating the fields. So cultivable command area means irrigated land, that is irrigatable land that is present in the gross command area, and then based on this we will calculate the intensity of irrigation. And what exactly is intensity of irrigation? Is the area that is actually irrigated in the field is called intensity of irrigation, and how you are going to use that intensity of irrigation in solving the problems, and different other definitions like time factor, crop factor, everything will be discussed in the definitions chapter. Next, crops and cropping pattern. This one and this one will be interlinked. Crops and cropping pattern and base period, duty, delta will be interlinked, and questions are generally made both in GATE and engineering services. So crops and cropping pattern, different types of crops. Cropping pattern, like what are the seasons we have? We have Kharif season, summer season, Rabi season. Like in Kharif season, what are the crops? The best example for Kharif crop is rice, and best example for Rabi crop is wheat. So what are the different types of crops? You have to have an idea. They directly ask you question like wheat and rice are made, and which intensity is this one. So calculate delta, calculate duty, calculate the base period for different crops. So this is how they are going to frame the questions. So you have to remember different types of crops. What is the cropping pattern? I mean Kharif season, what from which month to which month it is Kharif season, from which month to which month it is Rabi season. Rabi season is generally from October to February. So that's how you have to remember, and every crop and every cropping pattern, crop, and after rice crop, can you directly grow for wheat crops? No, you have to use some leguminous plants in order to increase the nutrition of the field, and then sometimes you have to keep the crop barren lands, because automatically it has to generate some strength for growth of other crops. So all those things will be discussed in this crops and cropping pattern, and you have to remember what are the crops that is done in different seasons, so that you can apply this over here, and the questions are generally solved based on this one, crops and cropping pattern, cultivable command area, gross command area, which is interlinked with base period, duty and delta, and very basic questions. While solving the questions, you will come to know that these are very basic questions, and this is just simply remember there is one relationship, and you will read this, that in Kharif season this is the crop, and these two parameters will be given, and third parameter is to be calculated. That's it. And in engineering services, this one, and irrigation efficiencies, these four things will be interlinked, and questions will be asked, and those questions will also be discussed in P-Drive courses. And previous year's questions and non-GATE questions, non-PSU questions, non-ESC questions will also be discussed in P-Drive courses. That means I will be discussing all those questions in the classes, and a material will be given to you in which all the questions will be there, and there will be a separate pattern or separate part where you will be having practice questions, and those practice questions or solutions for those practice questions, a group will be created in whatever the social networking site, whether it is Facebook, Twitter. A group will be created. In that group we are going to post you the solutions for different questions. Now after this one, losses of water in the canals. What are the different losses? See, basic idea. When water is flowing in the canal, what are the different losses? Evaporation losses, seepage losses, next, percolation, absorption, waterlogging, different losses of the water in the canals will be there. In order to overcome these losses, you are going for lining of the canal. Seepage has to be reduced, and then evaporation, you are going to reduce the evaporation. How you are going to reduce the evaporation? Generally, mechanical covers are provided, thin films are provided, so all those things. But how you are going to reduce the seepage will be discussed here, but how you are going to reduce the evaporation will be discussed in the hydrology. So losses of water in the canals will be discussed here. I mean, this is a theoretical question, and this theoretical question is generally asked in engineering sciences but not in your GATE. Next, design of canals. This is the important topic in canals. So design of canals, if you see, it is designed based on Kennedy's theory, Lacey's theory and Shields theory. Kennedy's theory, it is somewhat tiresome, but this is based on non-silting and non-scouring velocity. So what is non-silting, non-scouring velocity? That means while water is moving, the particles will not silt up, or it does not get sedimented, or it will not take the soil with it. That means the water is not coming with that force. That is non-scouring velocity, non-silting velocity. So Kennedy's theory is based on non-scouring velocity and non-silting velocity, and there are many limitations for the Kennedy's theory, because we are going to assume many things. A Cutter's equation is applicable and all those things. Many equations and many limitations will be there for Kennedy's theory. So all those limitations is overcome in the Lacey's theory. So Lacey's theory, engineering service questions, the many questions are asked on Lacey's theory. Direct application, there will be 6 formulas, apply those formula, then you will get the Lacey's theory. And in Lacey's theory, the idea is there will be initial regime, true regime and final regime. That means initial regime, what is initial regime, what is final regime? A canal gets adjusted. In initial regime, side slopes get adjusted, and in final regime, the bed slope gets adjusted. How it is how does it gets adjusted, and in different soils, whether in fine grained soils how it gets adjusted, in coarse grained soils how it gets adjusted, everything will be discussed in your Lacey's theory. From engineering service point of view, Lacey's theory and Kennedy's theory is important, and from GATE point of view, sometimes in some questions they have directly asked the formula of Lacey's theories. So it is important to remember, those are empirical equations, so that will be given to you in your P drive courses. So you have to remember that equations in the Lacey's theory. Next, Shields theory. Shields theory is based on tractive forces. That means when water moves, when water flows in the canal, if the canal is made up of earthen channel, or earthen canal means there is earth, so there will be soil particles. So soil particle, water is moving on a soil particle, or water is moving like this, right? So there is a tractive force that is called shear stresses or shear forces on the sides as well as on the bottom. So the water flow should be such that it should not carry the soil particle with it. So if you design keeping this in the mind, keeping tractive force theory in the mind, then it is called Shields theory. And design of canals, all these theories we are going to design, or we will learn the design of canals based on all these 3 theories. And this is also asked, this is also important from engineering services point of view, and many a times just a formula is asked, but no questions, no application is made in GATE, and in your state public services also questions are not made. A direct formula will be asked from Lacey's or Shields theory, but in engineering services you will see a good quality of question, because majorly questions are asked from Lacey's theory and Shields theory only. Next, after coming of canals, designing of canals, that means I told you that there will be seepage of water, right? So water gets seeped into the ground. So this seepage has to be arrested. this seepage has to be arrested. That can be done by lining of the canals. Lining means what? You just construct a concrete structures, or you will provide a shape to the canal. You will provide a shape to the canal so that water losses or seepage losses will be less and economy will be more. So that is the idea of lining canals. The most efficient section or most economical section, you will get that from the lined canals. So we will discuss each and every concept in lined canals, like for triangular section, for trapezoidal section, how the line section will be there, and then economics of the line section will also be discussed. Economics, that means if this is the seepage is less, maintenance will be more. So how much increase in maintenance, how much savings in the seepage we will see, and finally whether it is gain or loss. We will apply different economical concepts over there, and we will see what is the gain, what is the loss by designing of whether you can go for lining or not. All those things will be discussed in design of lined canals. Next, canals are over. Now canals comes from dams. So coming to dams, so it's indirectly like, first we will construct a dam, water level will rise, water will go into the canal, and then water will go into the field. That's the idea. Dams, canals, and water goes into the fields. That's how it is linked. So dams, types of dams. Types of dams, it depends upon the types of material you are going to use. So earthen dams, there will be earthen dams, there will be concrete dams, there will be rock fill dams. So based upon the material, based upon the structural concepts, like whether it is gravity dam, whether it is non-gravity dam. What does gravity dam means? Gravity dam, in gravity dam, if you apply the force is being resisted by its self weight. That is called gravity dam. So how it is going to resist and all the other things we will be discussing in the gravity dams. Here we will be discussing only gravity dams, and then in types of dams I will also discuss designing of arch dams also will be discussed over here. Here I will be discussing gravity dams and arch dams. Now types, forces acting on gravity dams. Forces acting on gravity dams, different forces, like there will be water force, there will be uplift pressure, there will be self weight, there will be earthquake force, there will be silt pressure, there will be wave pressure, there will be ice pressure. So different pressures, how they are going to act and how you are going to resist, and based on that we will design the dam. So different types of failure. That means when water flows, water is flowing like this, there is a dam. It can overturn or it can slide like this. So there will be sliding, there could be overturning, there could be crushing, or there could be failure due to tension within the structure. So all those things, different modes of failure in the dam, and how you are going to see, this is also being considered while designing the dam. And finally, based on this one, you will draw elementary profile and practical profile of the dam. Elementary profile means what is the base width, what is the height of the dam. All those things is decided based on considering forces acting on dam and modes of failure of dam. So in dams there will be spillway section and there will be non-overflow section. Overflow section, non-overflow section. Overflow section is called as spillways, and non-overflow section, non-overflow section only. So spillways. So different types of spillways, like there will be Oogie spillway, chute spillway, and then trough spillway, siphon spillway. All the types of spillways will be discussed in analysis of gravity dams. So each and designing of Oogie spillway and designing of siphon spillway will be discussed over here, and in brief introduction about different spillways also will be discussed here. And this is important from engineering services point of view. Throughout the thing, everything is important from engineering services point of view, and from grade point of view, elementary profile and practical profile of the dam is important, because directly they have asked you the formulas for the base width and height of the dam. Just by seeing the, if you remember the formulas, there will be option over there, just take the option and then you will get your 2 marks. So that is the idea from the gravity dams. And doubts, if you are having any doubts, all those doubts will also be discussed in that social networking group. I mean, let us say if I created a Facebook group, in that Facebook group if you have any doubt, you can post that doubt and it will be cleared in that group. That is the idea. So this is important from engineering services point of view, and this one elementary profile and practical profile of the dam is important for your both GATE and public service, I mean state public service examinations. Now after the dams, the other irrigation structures are weirs, barrages. So weirs and barrages, major problem in weirs and barrages is when water is flowing, you have constructed a barrage. Difference between dams and barrages will also be discussed. Major difference is what? Here there will be storage and movement of water. Here it is only for supply of water. There is no storages in weirs and barrages. Compared to that of dam, storage in weirs and barrages is less, and compared to that of weirs, storage in barrages is very, very less. There will not be any pondages, any storages. So with the help of figures you can show. They directly ask what is the difference between weirs and barrages. In your interview question, they will ask you what is the difference between weirs and barrages. You will just draw a figure and you will show, and I mean I will give that figure in your P Drive courses. You will just draw a figure and you will show this is the difference, and that is enough. That is enough to crack your interviews. So that's how it has to be very, very short and crisp. Your answers has to be straightforward, short and crisp. That will fetch you good amount of marks. And types of theory of seepage, how water is seeping below the weirs and barrages, and Blake's creep theory, Lame's weighted theory, Kosla's theory. Here how, I mean you will be providing sheet piles. Piles will be provided in order to reduce the seepage. So even then the seepage occurs, but idea is to reduce the failure. Idea is to, because of seepage there will be undermining, piping effect will be there, there will be uplift pressure will be there. So we have to overcome all these things. So this is being overcome in Blake's creep theory, and there are the limitations for Blake's creep theory which is overcome in Lame's weighted theory, and the combined limitations of Blake's and Lame's weighted creep theory is overcome in Kosla's theory of independent variables. So now we are using this. Here you will be using the equipotential lines, and then I mean streamlines, which you would have heard in your fluid mechanics, equipotential lines and streamlines, and this is more or less equal to the practical thing that is happening in the field. So more questions. I mean generally in 2 years, if he wants to make paper tough, he will give question from here, Kosla's theory of independent variables. So here also if he wants to make the question tough, he will give question from modes of failures of dam. So you can't just neglect this one. When you do that type of question, you will be having an upper hand over other people. So here, and from engineering services point of view also, Kosla's theory of independent variables is very, very important, and Blake's creep theory, this is a simple theory, and if paper is easy, you will directly see a formula from here which you can directly apply. That means you read the formula from here and you will see the formula over there, you will tick it and you will get your marks. So Kosla's theory of independent variables. Here what are the streamlines, what are the equipotential lines, I mean what is the potential over here, what is the head over there, everything will be discussed, and what is the exit gradient. The limitations in Blake's theory will be overcome in Kosla's theory of independent variables, and this is what you are going to discuss in weirs and barrages. And coming to after this one, I will be discussing waterlogging effect. Initially I told you the disadvantages of irrigation is waterlogging. Waterlogging means what? There is a land and it is completely submerged in the water. So what happens? Actually plant requires water only, right, for its growth. Then what happens if there is more water? If there is more water, there will not be air. Air is also required for the roots for its growth. So because of waterlogging, the yield of the plant will be reduced. And how much it will be reduced? What are the other causes of waterlogging? That one loss is this one, other losses, breeding of mosquitoes, many infections and all those things will be discussed. This one, what are the effects of waterlogging, what are the causes of waterlogging? Causes of waterlogging is over irrigation, or sometimes the other person from his field, if he releases water onto the downstream field, it gets completely logged, so there will not be any growth of the plants. So all those things, effect of waterlogging will be seen. We are going to seeing the effects of waterlogging, and now reasons for the waterlogging will also be seen in this one. And then reclamation of saline and alkaline soil. Saline and alkaline soil means when you pour the water, the salts will be present on the land, right? So this salts has to be removed. So how you are going to remove those salts from the soil? That means by huge movement. That is one of the advantage by I mean, if there is one of the disadvantages, the other advantage would be if you discharge the water at the higher rate, or if you flood the land with the huge amount of water, huge amount of fresh water, then all the salts will be removed along with the water. So that is one way of reclamation of the soils. There are many other ways that will be discussed in reclamation of saline and alkaline soils. Next, design of subsurface drainage system. Why you have to design the subsurface drainage system? That means there is a land, there is a water. So in the bottom, I'll provide a pipe so that it sucks off maximum amount of water, and then only some amount of water is present over here, and this water is utilized by the plant for its growth. So this subsurface drainage system is designed based on waterlogging. So that's why it is provided, or this one is provided in waterlogging, and this is majorly important in your engineering service examination questions. This is a problematic questions. These are problems, and if they want to ask theories are asked from here and problems are asked from here. And recently both theory and problems are given equal weightage in your paper 2, so you have to read everything. And if this is a scoring one, this is a scoring one, and in GATE till now they haven't asked this question, but there is every possibility. That means, you know, if he wants you to surprise, then he will give you a question from here. It is somewhat lengthy, but if you practice it, it becomes easy and you can score well in this problem also. Next, after all the major topics, there are some miscellaneous topics like meandering of rivers. Here meandering means water will not always flow like this, it will move in this fashion. It will move in this fashion because of its speed. Sometimes because of if it is moving very slow, there will be sedimentation of the that means sedimentation of the particles that is present in the water. If it is moving at faster rate, there will be scouring of the soil, right? So because of that, the course of the water keeps on changing. So that is called meandering of rivers. This meandering of rivers, you know, in interviews they'll ask, you know, Ganga is a meandering river, so what is sinuosity, what is meandering, and if sinuosity is more than 1.5, what happens? If it is less than 1.5, what happens? What is meandering width, what is meandering length? So this is an interview topic. See, you can think that if I score well in my conventional part or well in my GATE exams, it is enough. No, interview is also equally important from both GATE and engineering services point of view. So meandering of rivers is also important. And then canal outlets. Last time a question is being asked from canal outlet. There is like non-modular outlets, semi-modular outlets, modular outlets. GATE question is being asked as the following. So very simple thing, 3 different types of outlets will be there, and each and every outlet, I mean, what is this outlet, what is that outlet, is basically based on water in the water course and the water outlet. or in the canal and the water outlet. I told you already different types of canals will be there, like main and branch canals, distributaries, major and minor distributaries, and water course and outlet factor. All these things depends upon the discharge it is being carried. Like if discharge is more than 30 cumex, if discharge is from 10 to 30 cumex, if it is from 1 to 10 cumex, if it is less than 1 cumex, what happens? That is for canal outlets. Based on that, you will say what are the different types of outlets: non-modular, semi-modular, modular. So these are the different types of outlets. Next, cross drainage works. Cross drainage works means what? A river is flowing, a canal is flowing. Now how you are going to overcome this? If canal is moving above, then you will construct a aqueduct, that is a cross drainage work. And if canal is moving below the river, you will you will provide a super passage, and there will be siphon aqueduct, there will be siphon, there will be level crossings, there will be inlet and outlet structures. All those things will come in cross drainage works. And we are going to here the design is not important from gate point of view, but design is important from engineering services point of view. So designs will also be discussed. Designs of cross drainage works will also be discussed over here. Next, fuming of the canals. Fuming of the canals means it reducing the width of the canal while overcoming the, that means a river is flowing like this, canal is flowing like this, will sometimes reduce the width of the canal. That is called fuming of the canal. How you are going to fume the canal, and means that means the width at the reduced portion and width at the normal portion. How you are going to do that, everything will be discussed in the fuming of canal. And under sluices means you are providing water below you are providing a sluice and you are transferring the canal water under it. That is the under sluices. What are its advantages and disadvantages will be discussed, but not the design, whereas fuming of canal designs will be discussed here. Next, river training works. River training work means how you are going to reduce the width of the river, or increasing the width of the river, increasing the discharge or reducing the discharge, different types of groins. All those things will be discussed in river training works. And this is here in canal outlets, you will see the flexibility and all those things. Here this is also sometimes will be asked in your objective questions of engineering service examinations. Till now no subjective questions has been asked from river training works. So what is affecting deflecting groins, and what is accepting groins, all those things will be attracting groins, not accepting groins, deflecting groins, attracting groins, all those things will be discussed in river training works. So these are the 10 topics. I have discussed the whole syllabus into 10 topics. You can see all the 10 topics over here. Each and every topic in detail will be discussed in your pen drive courses in a crisp format. That means if you read this properly, you can crack any examinations in India. Any examinations you can easily crack if you read this properly. And all those what are the references books will also be given to you in your P drive courses. You can go through that, but maximum this is enough. And notes also, while discussing in the P drive courses, you can prepare your own notes by sitting or just by listening to whatever I have been teaching over here. That is enough. If you write that one also, you get better marks. In GATE you might score up to 98, or the maximum was 90, 92 out of 100. So you can score up to that marks, whereas in engineering services the overall, like prelims, mains and interview combined, the first ranker will be in the range of 65 to 70% of marks. So here if you read each and everything properly, out of this 50 to 30 marks you can score 25 marks easily. This is a scoring subject, because many times you don't see theories over here, only problems is being asked. So if you solve the problems properly, so you can easily score in your engineering services also. And generally here a practice booklet. See, this is a practice booklet for both water resource engineering and hydrology, and here it is generally divided into 3 parts. In the first part I will be discussing previous year's GATE questions, and engineering service questions. That means questions will be given to you and answers or solutions will be discussed over here. That means I'll discuss the solutions and answers. And non-engineering services, non-PSU questions, that is part 3, questions will be given to you, I'll discuss the solutions. And there will be practice questions in the part 2 that has to be solved by you, and if there are any doubts, that will be discussed in a whatever the social networking site group. You will post your doubt and we will give you the solutions. So this is what I'll do in water resource engineering. And next one is hydrology. So hydrology, the weightage for GATE is 2 to 4 marks, engineering service examinations 50 to 30 marks. Both water resource engineering and hydrology weightage is more or less it's same. So same concept goes with hydrology also. You can't neglect it, because everyone, I tell you, the person who is seriously preparing for GATE or engineering service examinations will definitely score good in both hydrology and water resource engineering. So in hydrology also, you have the questions are very simple. You just have to score it, because more or less they will be asking problematic questions in GATE, and then engineering services also many problems will be asked from this hydrology, and theory is less. And theory also, the basic theories, I'll discuss that, you'll see while I'm discussing it. So first chapter in hydrology is definitions. The hydrology, the name itself says hydro means water, logos means study. It's like study of water, study of movement of water actually. So in definitions, hydrological cycle. In one of the engineering service examinations, they just asked you to explain hydrological cycle. Direct, if you just draw the figure of hydrological cycle, that was enough to give you 10 marks. Hydrological cycle means, I think in your 12th class you would have learned it, like precipitation, evaporation, infiltration, runoff. And there will be evapotranspiration, and there will be groundwater flow, there will be surface flow. All those things will be discussed in definitions. And here residence time, what is meant by residence time? The name itself says for how much time the water presents in the given format, or like in precipitation. Precipitation means what? Rainfall, so snowfall, glaze, drizzle, everything comes in precipitation. And then infiltration, then evaporation, runoff, each and everything will be discussed in hydrology. That is the different chapters over here: precipitation, evaporation, infiltration, runoff, surface runoff or subsurface runoff, which is also called as base flow. All those things will be discussed. And then what is water budget equation? So water, like financial budget, water budget, that is coming minus going is equal to change in storage. So all those things will be discussed in the definitions. And what is water catchment area, what is ridge? And here a 10 marks question, as I told you, 10 marks question was asked or based on hydrological cycle, and based on water budget equation also. One time they have asked in engineering service examinations, and basically in GATE they never touched this part in GATE, but they may surprise you by giving you the water budget equation from definitions. And coming to the next part, precipitation, which is the important part in hydrology. Many a time the GATE question is being asked from precipitation, and engineering service minimum 10 marks is being asked from precipitation. In precipitation, the name itself says precipitation means the mode of water, whatever the mode, if water reaches from atmosphere onto the earth, then it is called precipitation. It can be rainfall, it can be snowfall, it can be glaze, it can be drizzle, it can be sleet. So what are the types of precipitation and how you are going to differentiate all these things? What is drizzle? What is rainfall? On what basis you are going to change it, define it? Like if size of drop, intensity of rainfall, all those things will be discussed in types of precipitation and types of rainfall. There could be orographic rainfall, there will be conventional rainfall. So how you are going to differentiate all these types of rainfall? This is a theory question, and theory question is important in engineering service examinations. And cyclonic rainfall, all those rainfall, frontal rainfall, warm air, cold air, and anticyclones, cyclones, and what is the rotation of the wind in anticyclones, what is the rotation of wind in cyclones in northern hemisphere, in southern hemisphere. So what are the different effects because of which the cyclones occurs. All those things will be discussed in types of precipitations. Now definitions related to rainfall, as I told you, different types of rainfalls are there, and then coming to rainfall, what is annual average rainfall. Each and everything will be, whatever you do here will be expressed in terms of annual average rainfall, means on an average throughout an year what is the rainfall. Like last year it was 160 centimeters, this year 120 centimeters, next year 130, like for 30 years what is the average. So on an average in India it is 120 centimeters, that is annual average rainfall. That definition, or what is drought, what is flood. So different types of droughts, hydrological drought, meteorological drought, rainfall deficiency, everything will be discussed in the definitions related to rainfall. And here also this is a theoretical question, and here the question that might be asked is drought in the rainfall in the engineering service examinations, and droughts and rainfall deficiency is important. Rainfall deficiency may be asked in GATE, and rainfall deficiency will be asked in objective questions of engineering service examinations. Next, measurement of rainfall. This is important. Measurement of rainfall. There is non-recording type of rain gauge. For measurement of rainfall, we use an instrument called rain gauges. Non-recording type of rain gauges, recording type of rain gauges. What are the differences in non-recording, recording, and Simpson's type of rain gauges, and weighing bucket type, tipping bucket type of rain gauges. So if you know all those things, this is a theoretical question, but tipping bucket, weighing bucket type can be asked as problems, can be asked, very rare cases, but they can be asked as the problems. And Simpson's rain gauge, that is a theoretical question. They might ask you to explain and explain how you are going to record the rainfall by using Simpson's rain gauge, and how generally we are going to measure rainfall. Rainfall is measured in terms of depth. Like generally if you see 120 mm, 90 mm rainfall, 90 centimeters rainfall, 10 mm rainfall, it is the depth by which the water stands over the given area is called as rain gauges. And for how much area you have to provide one rain gauge, what is the density of rain gauges, all those things will be calculated in measurement of rainfall, or will be discussed in the measurement of rainfall. And this is also a theoretical question. And now coming to the average rainfall and design of rain gauge station, this is important. Optimum number of rain gauge stations, that means in order to increase the efficiency, in order to increase the accuracy, more number of rain gauge stations, more number of accuracy, but economically it will not be good. So what is the optimum number? A formula is given to you based on statistical data. So based on that you calculate the design of optimum rain gauge stations, and based upon the weighted theories also you can calculate the optimum number of rain gauge stations. Next, average rainfall. Average rainfall, let us say in a given area there are 6 rain gauge stations, or 10 rain gauge stations, 20 rain gauge stations. So for that area, if they ask you rainfall, what will you say? You have to calculate the average of it. For that you can use arithmetic mean method. So different methods are there. There are arithmetic mean method, Thiessen polygon method, isoheightal method. What is a isoheight? Isoheight is the line joining points of equal rainfall intensities. So all those things, each and every method is discussed in detail. And Thiessen polygon method, in GATE they have asked question on Thiessen polygon method. In isoheightal method also, isoheightal method is generally asked in engineering services, and arithmetic mean method also they can ask in GATE. Now coming to determination of missing rainfall data, this is very much important from GATE point of view. Here the missing rainfall data means there are 10 rain gauge stations, 9 rain gauge stations you have data for that year, or for that day, or for that time period, but in one rain gauge station it was not able to record it. There could be many reasons for it, many reasons for it, but how you are going to find that point is important. So missing rainfall data, you can go it by average value. So there is average method and there is a normal ratio method. When you are going to use average method, when you are going to use normal ratio method will be discussed in your PD courses by examples. So this is an important thing. Many a time you can see gate question is from this point. Gate question is many a time is from this point. Next, consistency of the records. Here double masker, a new technique called double masker. What is a masker? Masker means discharge with respect to time is a masker. Rainfall with respect to time is called a masker. That means a quantity, its variation with respect to time is called masker. Double masker means on both abscissa and ordinate. Both abscissa and ordinate you will find quantities, mass quantities only. Here also it is mass quantity, here also it is mass quantity, then it is called double masker method, and here it will be written in reverse chronological order to find the consistency of records. Means let us say one year it was 90 centimeters, other year also it is 90 centimeters, and suddenly it reached to 180 centimeters and then it reduced to 50 centimeters. So there is uneven change in the graph and the consistency of record is changed. It might be because of anything, because of natural effects or because of the throughout the surroundings is undergoing a gradual change, or it may be because of eye error, human error. So you don't know. In order to find out the correct value, you will use double masker technique for measuring consistency of records. Many a time this is asked in as the following. So the consistency of records, this both ESC objective and gate objective also this question is asked, 2 marks questions. So or 1 mark question also it can be asked in gate. Next, intensity, duration, frequency curves. This also plays an important role. Intensity, duration, frequency curves. That intensity, depth, frequency, it is also called as intensity, depth, frequency curves. Frequency is related to time period, depth, and intensity, higher depth, but higher time period, lesser depth. So how the curves changes will be discussed in detail in this IDF curves. Next, evaporation. So all these things comes in precipitation, and if you consider the losses of precipitation, first one is evaporation. That means water reaches the earth surface and then it goes back from the earth surface to the atmosphere, that is evaporation. Evaporation is more in oceans or rivers, where it will be more, why it would be more, everything will be discussed, and factors affecting evaporation like temperature, wind, vapor pressure, atmospheric pressure, depth of water bodies, how it is going to affect, and shape of water bodies, everything will be discussed in factors affecting evaporation, and this is important in your ESC theoretical question. And methods to prevent evaporation. So methods to prevent evaporation, that means water should not evaporate. You can provide mechanical covers, that means just go and cover the water so that water will not get evaporated. Providing some thin films, or by increasing the depth and reducing the area you can prevent the evaporation. So the different methods, each method in detail will be discussed, and this is also a theory question. And then methods to find evaporation, here as pan evaporation technique. Here this could be a problematic question. Pan evaporation, there is class A pan, there is Colorado sunken pan, there is ISI pan. So you'll in the lake, in the still water, you create a pan and you'll see how much amount of water is evaporating, and you'll use some coefficient to find the actual evaporation in the actual river. So all those things, river or actual lake, that is used to find the evaporation. So these are the methods, and there is one empirical method, a formula is given to you based on Dalton's law, that can also be used to find the evaporation. Now after the evaporation, I am going for stream flow measurement. Stream flow means name itself says, in the river water is flowing, you have to measure the discharge. Stream flow measurement means discharge measurement. So the discharge measurement, there are many methods for measuring the discharge, where you will measure the stage. Stage means depth of the water. Based on the depth of the water, you will give the discharge. Generally this is what you do. You'll see scales in the rivers, in the dams or anywhere you see the scales, and they'll measure the depth of the water. For this depth, this is the discharge. This was initially calibrated. A graph is there from discharge and stage curves. So from stage means depth. So based on this depth, this is the discharge you will give. That is stage discharge curves. That is one way of measurement. Next, other way of measurements is there are direct methods and indirect methods. Direct method means discharge is area into velocity, right? So we have to measure velocity. So velocity can be measured by using floats and current meter. Current meter is an instrument used to measure the velocities. So velocity, current meter, floats. Floats means a small a piece of paper or piece of cardboard is being sent on this one. The distance traveled by time, you can get the velocity, and then current meter. So current meter also you can find out the velocities. Current meter instrument which is having sounding weight, and then it will be moving in the horizontal direction. It will be moving. It can be moving in vertical direction also. From this you can measure the velocities. So based on velocities, area into velocity, and there will be many other methods, moving boat methods, dilution method, ultrasonic methods. All those comes under direct methods. Indirect methods is like construction of structures, weirs, and there is slope area method. Each and every method will be discussed in detail, because this is also from engineering services point of view. Many a time a current meter is being asked for gate, and these methods is asked in engineering service examinations, but this is a scoring point, from the scoring marks from that point of view. Now coming to flood measurement, I have discussed stream flow measurement. Flood measurement. Flood is a characteristic situation where discharge is very much high, either in the river or on the field, wherever. Flood is a situation where this is the normal water level and there is a sudden rise in the water level. How much this rise or how much this discharge, calculation of this discharge is flood measurement. For that, a rational method, that means for urban areas where flow area is less than 50 hectares, you can go for rational method where discharge is calculated based on runoff coefficient, rainfall intensity, area. If you substitute that in formula, you will get this one. In a ESC question, this is being interlinked with environmental engineering. This formula is interlinked with environmental engineering. So, interlinking of questions will also be given in engineering service examinations. Sorry. Next, there will be empirical equations, that is Rice formula, Dickens formula, English formula. Depending upon the different place situations, empirical equations are generated. So the equations can be asked in objective questions, and in subjective till now they haven't used it. Now probability method. Probability method means, let us say 100 cubics of discharge can occur for 100 years. So that means that is the probability. So the chance of occurring that in 200 years is 2 times. So what is the probability of occurrence of that flood in these many years or these many times? So we are going to find out that probability, and based on that probability we will design the structure. So we will calculate the design discharge from that probability method. There are 2 types of probability methods: theoretical probability method, statistical probability method. There are Gumbel's equation, statistical probability method. There is a return period. What is return period? Return period means for after how many years this much amount of flood or this much amount of rainfall comes. All those things will be discussed in probability method. And other method of measuring the flood is hydrograph and unit hydrograph. Hydrograph is the variation of discharge with respect to time. Discharge means water is flowing on the land, that means runoff, right? Variation of the runoff, with indirectly it is variation of runoff with the time. And unit hydrograph, why? What is the difference between direct runoff hydrograph, unit hydrograph, flood hydrograph? Everything will be discussed in hydrograph and unit hydrograph. The same concept is seen in runoff also. Use of hydrograph and unit hydrograph means this concept is actually discussed here, but by using this also you can measure flood measurement. Flood is also measured like this. Flood means indirectly we are measuring the discharge only here also. Here it is in stream, here it is flood, that means very rare situations. Now after runoff, after flood, infiltration. This is also one of the laws of precipitation. So infiltration means water is entering into the ground, that is considered as infiltration. There is so here we will see what is infiltration, what is percolation, what is seepage, differences between all these things. Next, losses due to infiltration. Losses due to infiltration would be depression storage, interception losses. What is this? Depression storage means, water is stored on the top surface. It is not entering into the ground, that means it is not infiltrated, that is considered as infiltration loss. And interception losses, that means water sometimes absorbed on the top of your house, it is not entering into the ground, right? So or sometimes the water water is absorbed by the plant, it is not entering into the ground. All those things comes under interception losses. So what are in depth we will be discussing over there, and there is no problems on this, it is only for theoretical concept. But Horton's equation. Horton's equation is to calculate the amount of infiltration that is actually occurring in the field. That means initially the infiltration will be more, over a period of time the infiltration keeps on reducing and it becomes constant after some time. So that exactly how much amount of infiltration it is occurring and what is that equation, how to use that equation will be discussed in Horton's equation. And this more number of times a problem is asked from Horton's equation. So this is also important from GATE point of view, and in engineering services it is not asked that much, but it is also important from engineering services. But from GATE point of view this equation is important. Next comes more important thing, infiltration indices. This is important from GATE, engineering service examination, state service examination, whatever the examination. Many times you will see a question based on phi index, W index. Phi index, W index, average infiltration rate. Phi index or W index, average infiltration rate. This is also average infiltration rate. How you are going to calculate phi index? That is, what is average runoff over here? Everything. That means rainfall above phi index is called as runoff. So phi index is considered as average infiltration rate. Here a concept called hydrographs comes into the picture. What is hydrographs? How to calculate phi index based on trial and error method. Everything will be discussed here. So this concept is very much important from both GATE point of view as well as IS point of view, whereas state services point of view also phi index and W index is very much important. Next, coming to runoff. Runoff means precipitation, water goes infiltration. Next, whatever the water that is flowing on the ground or just below the ground, it is considered as runoff. Types of runoff, there will be direct runoff, there will be base flow. So runoff means surface runoff, so water flowing on the surface and then finally it reaches to the ocean or nearby rivers. And then from the bottom, base flow means below groundwater flow will also finally reach to the rivers. So all those things comes under runoff. So types of runoff, direct runoff, base flow, everything will be. So this, what is direct runoff, what is base flow, I told you right now, but in depth will be discussed in types of runoff and how you are going to find out. There will be empirical formulas. So and there will be, as I told you, hydrograph and unit hydrograph, more amount of questions. Here also if he wants to make somewhat critical questions or typical questions, generally it is an easy questions. If he use S-curve concept, it is somewhat lengthy. So why, if he is using S-curve concept, then if you do that problem, you will be at the top. Believe me, you will be at the top, because this is an comparative examination. If no person is doing that and if you are doing that, then you will get better marks or better rank. So This is an important concept here. Hydrograph, unit hydrograph. If unit hydrograph is given, how you are going to calculate direct runoff hydrograph, how you are going to calculate flood hydrograph, direct runoff hydrograph plus base flow gives you flood hydrograph. All those things will be discussed in use of hydrograph and unit hydrograph. Next, use of infiltration curves. By using infiltration curves also, that means precipitation below the curve, below the infiltration curve it is infiltration, and above the infiltration curve it is runoff. So all those things will be seen here. Next, use of coefficient of runoff. Coefficient of runoff means let us say 65% of precipitation is going as runoff. So coefficient of runoff is 0.65 times runoff, 0.65 times precipitation is runoff. That is the idea. So all these things is used to calculate the runoff, and more important thing from examination point of view is hydrograph and unit hydrograph, and this will be discussed in detail over here, and problems will be given for here also. That means if he wants to make question somewhat, you just have to think. If he wants to make you think, he will gives you infiltration curves, and this empirical method and coefficient of runoff, this is might be asked in your engineering service examinations but not in the gate. Next, in synthetic unit hydrograph, this is purely theoretical concept. He will give you here I will discuss you a hydrograph and empirical equations will be given to you. Remember that equations and then use that equations for calculation of discharge or calculation of runoff. That is the idea from runoff. Now once runoff is done, with this losses are done, now idea is flood routing. Next chapter is flood routing or flood routing means idea is, if suddenly water level, more amount of rainfall comes, what happens? Flood is occurring. Flood is occurring means huge amount of discharge is coming and you have to release that discharge. So what you have to do is, dams or some irrigation structures are constructed to reduce the flood or to reduce the peak. So that is the idea, that sometimes dams are also constructed to reduce the peak. So that is called flood routing or flood routing. So this flood routing, the structures that is constructed or the dams that is constructed to route the flood, it could be hydrological flood routing, hydraulic flood routing, depending upon the situation. How you are going to do this? There will be channel routing, there will be reservoir routing, and what is linear channel, what is reservoir channel, and we'll do a problem. With the help of problem, we'll route a flood. There will be inflow hydrograph, there will be outflow hydrograph. How much amount of storage will be there? What is the change in the storage? Where you will get maximum storage? All these concepts will be discussed in flood routing. And this is important from engineering services point of view and from gate point of view. Sometimes they have asked what is the difference between hydraulic flood routing and hydrologic flood routing. That is in the match the following, and that will also be discussed in flood routing. Next, coming to miscellaneous concepts, instantaneous unit hydrograph. What is an instantaneous unit hydrograph? That means it is a hydrograph generated for instant rainfall. It is a hypothetical concept, but these type of things is also asked in the examinations, mainly engineering services. They will ask you in engineering services objective questions, not in subjective questions. Next, depth, area, duration curves. What is the amount of depth, what is the area it is occupying? If area is more, depth will be less. If depth is more, area occupied will be less. And what is the duration? If duration of rainfall is more, what happens to the depth, what happens to its variation with the area? Everything will be discussed in depth, area, duration curves. And what is the probable maximum precipitation that can occur in the area? Probable maximum precipitation, by using probability method, I told you will calculate that. The same thing, this is also a hypothetical concept. And then standard project flood. So, and then probable maximum flood. So standard project flood is approximately 65% of probable maximum flood. All these concepts, these are objective questions. match the following questions. These things will be very useful. And the major things you have to see in hydrology is precipitation, and from gate point of view, precipitation, infiltration, runoff, and from engineering services point of view is precipitation, evaporation, flood measurement, stream flow measurement, and hydrograph and unit hydrograph. Indices, very less time you will see indices being asked in engineering questions, but from gate point of view index is very much important. And application of, that means the indices is used in hydrographs. How you are going to use that, how you are going to generate that question, we will see the questions, we will discuss that, and then we will finish it off. That is how it is being done. And the same thing, there will be 3 parts here also in the booklet. There will be 3 parts. In the first part, previous year's questions will be discussed. In the last part, non-gate, non-PSU questions will be discussed. The solutions will be given by me in this booklet. The questions will be there and the solutions will be given by me, and the second part, practice questions, has to be done by you, and if there are any doubts, the doubts will be posted in a group and answers will be given by me. So this is all the introduction about water resource engineering and hydrology for the PD courses. Thank you.